Hello, good evening. Welcome back to another lesson of science of class 10th. Today we are going to discuss about chapter 1, that is chemical reactions and equations. Before going further and study more about chemical reactions and equations, let us first understand about change. Because change is something that brings about those certain chemical reactions. We can understand change as when the final state of a particular substance or element, or we can say compound, is different from its initial state. So, when a particular compound or substance undergo certain changes and its final state is different from its initial state, so that particular condition is regarded as change. So we can classify changes into two categories, that are physical changes and chemical changes. So physical changes are the changes which can be reversed. Okay, so in physical changes, we are not undergoing any chemical modification or the modification in the composition of that particular element. Whereas when we are discussing about chemical changes, so in chemical changes, we are undergoing certain uh, changes which cannot be reversed. Okay, so physical changes are somehow reversible, whereas the chemical changes are irreversible. We cannot reverse these changes. So when we are discussing about burning of a candle, so when we are discussing that the candle is burning, so a few chemical changes are taking place at that particular place of time or that moment, because when it is burning, it is resulting in the release of certain harmful gases like carbon dioxide, carbon monoxide, etc. So these gases cannot go back. Like we cannot undone this particular task, right? So this particular activity, that is burning of candle, is regarded as chemical change. Whereas in the same scenario, when we are discussing about this wax which is melting, so the melting of wax would be a physical change, because we can again solidify this particular wax. So in this particular picture, which is burning of candle, so the burning of candle is basically a chemical change. So this is basically the chemical change, because the combustion is taking place. We are burning the fire. So that is causing a few chemical changes. So that would be a chemical change. And the melting of wax is a physical change. Okay, so another example we can take of this fire. The fire is burning over here and it is resulting in the formation of ash. So we are burning wood and it is resulting in the formation of ash. So we cannot undo this process. We cannot make wood from the ash. Whereas we are burning the wood to form ash. Okay, so this is a chemical process, because the chemical properties or the composition of wood is different as compared to that of ash. So the composition of the particular element or substance is getting changed in the chemical changes, whereas the state or just uh, structural modification are taking place in physical changes. For example, when we are boiling this water, okay, so this water gets evaporated and it is converted into water vapors. So the state is getting changed, but the properties of water will remain same. Water is what? We write it as H2O. So water would still contain two molecules of hydrogen and one molecule of oxygen. Either it is present in liquid state or it is present in gaseous or in vapor state. So the chemical composition is still same, but the state is changed. So it would be regarded as a physical change. Similarly, the melting of ice would be regarded as a physical change, because ice is what? Ice is water in solid form. So the form of water is getting changed from solid to liquid. But water is water. Water is same. So it would be regarded as a physical change. Another example we can discuss of is rusting of iron. So you might have heard that when iron comes in contact with air and moisture, its color gets changed. So it is because of a chemical reaction. So because of the moisture present over the surface of iron and oxygen present in the atmosphere, certain chemical reactions takes place that we usually regard as oxygen. We are also going to discuss these reactions further in this chapter. So these reactions are taking place at the surface of iron, which are changing the chemical properties, which are resulting in the formation of iron oxides and hence change in the color of iron nail. Right? So these are the chemical changes. Okay, so here are a few processes or activities. So we have to identify whether the environmental change is a physical change or a chemical change. So first is melting of ice, as we discussed previously, that melting of ice is a physical change, right? Okay, then burning of dry leaves. Burning of dry leaves is doing what? It is a chemical change because it is leading to the release of various harmful gases, carbon dioxide, carbon monoxide, nitrous oxide, etc. Okay, so it is leading to the release of these gases into the atmosphere. Also, the composition of dry leaves is getting changed into ash. So it is a chemical change. And also, one more thing that we must keep in mind, that chemical changes are irreversible and physical changes are reversible. So we can also modify the liquid into ice again, but we cannot convert the ash into dry leaves again. So hence it is a chemical change. Okay, so then breaking of a tree branch. Breaking of a tree branch is a physical change, though we cannot uh, reverse this particular process. But the tree can further grow more branches, right? So tree breaking of a tree branch is a physical change because nothing, no composition of that particular branch is changing. So breaking of a tree branch is physical change. Then again, burning of candle, as we discussed in the previous discussion, that burning of a candle is a chemical change, whereas melting of a wax is physical change, right? Then again, tearing of paper is not undergoing any chemical change. It is a physical change because we can also reverse that particular process, or how many we can do many number of pieces of a particular paper, but the paper would be paper. So we are not modifying the properties of a paper. So it is a physical change. Then again, vaporization of water is a physical change because water is water, either it is present in solid form, liquid form, or gaseous form. Then cooking of food. Cooking of food is what? Chemical change because it is leading to the aroma that we usually smell. Also, the chemical properties are changing, or the food is getting cooked and its properties are changing. Its nutrient content is getting changed. Certain carbohydrates are forming, certain other proteins or amino acids are synthesized, and hence it is a chemical process. Okay, so then formation of curd from milk is again a chemical process because has certain different properties which are changed by the introduction of lactobacillus bacteria, and the lactobacillus bacteria further grows and changes it into curd. Curd is of different taste, milk is of different taste, so the properties are getting changed and we cannot reverse this particular process. We can make curd from the milk, but we cannot make milk from the curd, right? So it is a chemical change. Again, so chemical reactions. Now coming to our topic, that is chemical reactions. So chemical reaction is basically a process in which a substance undergo a transformation that results in the formation of a new substance with different chemical properties. So the chemical properties of a particular substance are getting changed over here. So when we are discussing about chemical change, so chemical change is taking place in that particular reaction. Okay, so these are the chemical reactions. Then there are a few indicators of chemical reactions. Like how can we know that a particular chemical reaction is taking place in this particular compound or in this element or in this particular substance, right? So there would be a change in color that would identify that it is a chemical reaction. Like previously that we discussed that the iron nail, rusting of iron nail was taking place, right? So the iron nail's color was previously grayish. Gray color was getting changed into brown, right? So that was an indicator of what? Chemical reaction, right? Okay, so the change in color basically signifies chemical reactions. Then other thing is change in state. Change in state also signifies chemical reactions because states can be many, like it is of solid, liquid, gas, or aqueous. Aqueous state is basically when we are dissolving a particular substance in water. So that particular solution would be regarded as aqueous solution, right? So state we must keep in mind that state can be solid, liquid, gaseous, and aqueous, right? Okay, so if there is a change in state, suppose we are dissolving a particular salt, suppose salt, we are dissolving salt in water, right? So the properties of salts have changed now. Okay, so now can we undo this process? No. So this particular process would be regarded as chemical change, and the particular indicator would be how would we know that the change state has changed? So the properties has changed, and now the chemical reaction is taking place. Okay, so there would be a change in temperature as well. So when we are discussing about burning of a candle or burning of wood or burning of dry leaves, so what we are doing, we are that particular substance is undergoing a certain change in temperature. So temperature is getting changed for that particular state, and that change in temperature is leading to chemical reactions. Suppose the fire was there, so we were burning few dry leaves, right? So dry leaves were undergoing change in temperature. Temperature was rising very rapidly because of fire, and hence the dry leaves were converted into ash. Then again there would be an evolution of gas. So जहाँ भी कोई chemical reaction हो रही होगी, there would be a release of certain amount of gases. Okay, so evolution of gases. When we were discussing about burning of wood or burning of candle, there was, I already mentioned that a certain amount of gases, few gases would release. Okay, there would be some emissions of either carbon dioxide, nitrous oxide, or carbon monoxide. So there would be an evolution of gas, and evolution of gas is an indicator of chemical reaction, right? Then again there would be formation of precipitate. Precipitate you might not know, so we would discuss in further discussions that what are precipitates. But briefly, precipitates are basically the substance which are formed after a chemical reaction occurs, right? So this was it about chemical reactions. And now moving to our next topic, that is chemical equations, right? So chemical equation, what is a chemical equation? So we can represent a chemical reaction using symbols and formulas, and that particular reaction that we have written down with the help of symbols or formulas will be regarded as chemical equation. Okay, so chemical equation is none other than but the chemical reaction that we have simplified and used symbols or formulas to to express a particular chemical reaction that is taking place. So suppose I would say that the magnesium oxide, yeah, suppose I would say that magnesium is getting reacted with oxygen, and further it is leading to the formation of magnesium oxide. So that would be a different thing. Instead, if I use this particular term for magnesium, I have used Mg getting reacted with, for indicated by plus sign, then oxygen is O2, and it is resulting in the formation of magnesium oxide, that is MgO2. So chemical equations makes the representation of a chemical reaction very easy and convenient. So in a chemical reaction, there would be a reactant as well as a product. So reactants are those species which are initially taken, or the initial conditions or the initial substance that is undergoing change, or those two substances, or if there is one substance or two substance, whatever it is. So it is undergoing change, and hence resulting in the final product that would be regarded as product. So it is the initial input, and this is the final output, right? So reactants do react with each other to form a final product. So in this particular reaction, where magnesium is reacting with oxygen and resulting in the formation of magnesium oxide, so magnesium and oxygen would be regarded as the reactants, whereas magnesium oxide, that was the final output of this particular reaction, would be regarded as product. So there would be a reactant or two reactant or three reactant depending on the equation, and there would be a product or two product or a number of products. Okay, so this is it. So, you might have seen this particular table in your class ninth NCRT. So, this is to make you familiarize with represent, how do we represent the chemical equations. So we know that we have to represent these chemical equations with the help of certain symbols and formulas. Okay, so we must know that what are their formulas and what are their valencies, so we can correctly represent these formulas. So we have written O2 with these, but we have written Mg. So Mg is, we are taking just one molecule of Mg, whereas O2, oxygen is represented by O2. So why so? This is because of the valency. So oxygen has -2 valency, and sulfide also have -2 valency, nitrites have -3 valency, then iodine has -1, bromine -1, chloride -1, hydride -1, hydrogen +1, ammonia +1, hydroxide -1, nitrate -1, then carbonates -1, carbonate -1, sulfide, sulfite -1, and sulfate -2. Sorry, sulfite -2 and sulfate also -2. Then phosphate is -3, again sodium +1, potassium +1, silver +1, copper +1. So we must keep in mind about these valencies when we are writing the chemical equations, because the representation of the element, for the representation of element as well as compound form of a particular element can be uh, correctly represented. It can be correctly represented with the help of valencies, right? So you might have been familiar with that, this as well. So let's move ahead. So next topic is balancing of chemical equations. So how do we balance chemical equations, and what is the need of balancing chemical equations? So you might remember the law of conservation of mass. This law states that mass can neither be created nor be destroyed, but it can be transformed from one form to another form, right? So the balancing of chemical equations is based on this particular law, that when the reactants are reacting to form a particular product. So the mass of a particular element should be same on both sides of the reaction. Either it is reactant side or product side, or it is left hand side or right hand side. It must be equally distributed, right? So there are in order to do that, we have to balance chemical reactions, and there are these few steps for balancing chemical reactions. First is to write the unbalanced chemical equation. So, suppose we have this particular reaction, right? So, how does water form? It is H2 plus O2 gives H2O, right? So this is the particular reaction. H2 plus O2 gives H2O. Hydrogen is reacting with oxygen to give water, right? So this is kind of unbalanced reaction because there are two atoms of hydrogen over here and two atoms of oxygen over here. But in the product side, there are two atoms of hydrogen, whereas just one atom of oxygen, which makes it quite imbalanced because to follow the law of conservation of mass, we must balance it. Okay, so how would we balance? Firstly, we'll count the atoms on both sides. Then we will use coefficients to balance this particular equation. So how would we do that? Okay. So we will write our chemical or elements over this side. Okay. Then the number of atoms on reactant side and number of atoms on product side. So we have two elements, that is hydrogen and oxygen, right? So the number of atoms of hydrogen on reactant side are 2 and oxygen are also 2. Then number of atoms of hydrogen on product side are 2, okay, 2, and number of atoms of oxygen on product side are 1, right? So from here we can conclude that it is 1. So how would we do that? So we have to balance this particular reaction. So in order to balance this particular reaction, we will multiply the product side by 2. So if we would multiply this particular side by 2, so this would be 2 and this would become 4, right? And to balance this, the oxygen atoms would be 2. Okay. So we have to make it to 2 now. So it is 2 now. Now we will multiply this with 2 as well, and hence the balanced chemical reaction would be H2 plus O2 gives 2H2O. So this is the balanced chemical reaction. So there are 4 atoms of hydrogen on both sides. 2 into 2 is equals to 4. So 4 on this side, 4 on this side as well. And 2 on this side and 2 into 1 is equals to 2, 2 on this side. So now this particular reaction can be said to be a balanced chemical reaction. Okay. So also, while balancing a chemical reaction or to make a particular chemical reaction, when we write a particular chemical reaction, to make it more informative, the physical states of the reactants as well as the products are also mentioned along with their chemical formula. So, for example, in this particular reaction, so this is the reaction from your NCERT. So with Fe is what? Iron. There is S written over in bracket. Then again H2O is G, and then again S and G. So what these symbols are indicating that iron is present in solid form, that is represented by S, right? So S represents solid form. Okay. Then again G represents gaseous form. So water is introduced in the form of vapors, or we can say it is present in the form of moisture that is present in the air, and then it is resulting in the formation of iron oxide. So iron oxide is again in the solid form, and then H2 is a gas which is released into the atmosphere. So this is the reaction of what? So this is the basically the reaction of rusting of iron. So there was iron and it was reacting with the moisture that was present in the air, and it was leading to the formation of iron oxide, and hence the hydrogen gas was released into the atmosphere. So in this particular reaction, we are writing the physical states of all the reactants as well as the products, so as to make the reaction more informative. Okay, so the gaseous, liquid, and aqueous or the solid state of the reactants and products are represented by G, L, AQ, and S respectively. Then again, the word aqueous is written if the reactant or product is present as a solution in water. As I previously mentioned, that when we dissolve a particular element or a compound or a substance in water, so if it is present in water, so that would be regarded as an aqueous solution, or that state would be regarded as aqueous. So we would write aqueous when it is present in water. For example, in this particular reaction, so this is the reaction of photosynthesis, right? So 6HCO2 plus 12H2O gives C6H12O6O2 and H2O. So CO2, where is this CO2 coming from? So plants are transpiring, plants are breathing as well. Okay, so they are taking up oxygen from that. Also, they are taking up oxygen from the roots. Okay, so that is present in aqueous form because that has water associated with it. Then again, water is present in liquid form, in the form of water that we give to the plants. Then again, the glucose that is forming is present in aqueous form again. Then oxygen is also present in aqueous form, which is transpired or respired after the reaction. And then water is again present in the form of liquid. Okay, so the word aqueous is written as AQ in the react if it is present in reactant or product or wherever it is. So it should be present in the solution in as a solution in water. Okay, so we must write solid, liquid, gas, or aqueous, whatever the state of that particular substance or component is, to make the reactions more informative, right? Okay, so let's move ahead. So now our task is to write the balanced chemical equations for the following. So the solution of barium chloride is and sodium sulfate. So now we know that the solutions of barium chloride and sodium sulfate are in water reacts to give insoluble barium sulfate and solution of sodium chloride. So the reaction is taking place in water, right? So the barium chloride and sodium sulfate are present in water, right? So we must write the state of barium chloride and sodium sulfate as aqueous. Now we know that. Okay, so here the solutions of barium chloride and sodium sulfate are reactants, of course, and they are reacting to give product that is barium sulfate and sodium chloride. So how to write this? Okay, so now we would write this particular reaction in the form of a balanced chemical reaction, right? Okay, so how would we write this? So we have barium chloride. Barium is what? Ba, right? Barium is represented with Ba. Then chloride is Cl2. BaCl2 is barium chloride. Then we would write aqueous over here. Then barium chloride is reacting with sodium sulfate. Sodium is Na sulfate is Na2SO4, right? So it is reacting, both of these are reacting. Sodium sulfate is again aqueous. Okay, so they are reacting to form barium sulfate. So BaSO4 plus. So the barium sulfate is solid because it was mentioned, plus NaCl, sodium chloride, which is again aqueous, right? So let's get back to our reaction that mentioned that the sodium chloride, sorry, the barium chloride and sodium sulfate in water, we have mentioned aqueous, reacts to give insoluble, hence it is solid, and the insoluble barium sulfate and the solution of sodium chloride. Solution mentions from solution we know that it is aqueous, right? So is this reaction balanced? Let us just check. So there is one atom of barium over this side and one over this side. Very good. Barium is balanced. Then there are two chloride atoms on this side, whereas over this side there is just one atom. So chlorine is not balanced, right? Then again, let us check that Na, sodium has two atoms over the reactant side, whereas it has just one atom on the product side. Then again, let us check SO4 sulfate is balanced again. So Na and Cl. So it sounds so clear and easy that if we would multiply this particular component with 2, so the reaction would be balanced. Okay, is it clear? Okay, so this is our balanced chemical reaction of barium chloride and sodium sulfate. Okay, so next now move towards the another reaction that was mentioned, that sodium hydroxide solution in water, means sodium hydroxide is aqueous. Okay, so sodium hydroxide reacts with hydrochloric acid, which is again in water, so it is again aqueous, to produce sodium chloride solution. Answers our question of state that it is aqueous and water. So sodium hydroxide solution, sodium hydroxide is what? NaOH, NaOH, NaOH is in aqueous state, is reacting with hydrochloride. Okay, so it is again hydrochloric acid is again aqueous. So sodium hydroxide is reacting with what we call this HCl. Okay, so it is reacting with HCl and it is resulting in the formation of what? Water and NaCl in aqueous form plus water is what? Liquid. So water in liquid form. Okay, so let us just check if the reaction is balanced. Okay, so sodium hydroxide has one atom over the reactant side and one atom over the product side as well. Okay. O oxygen, there is one oxygen atom over here. Hydrogen, one atom, two atoms total, and two atoms over this side as well, right? Then again, fluoride, there is one atom. So the reaction is already a balanced chemical equation, right? So this is how we balance our chemical equations, or how we write a balanced chemical equation. So there are a few practice questions or equations that can be used to practice the balancing of chemical equations, right? So the first is H2 plus O2 gives 2H2O. So we previously already we have already done this particular reaction that it would be regarded as 2H2 plus O2 gives 2H2O, right? So this is how we would write this particular reaction. Then again for N2 plus H2, how would we balance this? NH3. So there are two atoms of nitrogen over here. So we would multiply this by 3. Then hydrogen, how many atoms we have? 3 multiplied by 2, 6. And here only 2. So how would we make 2? How would we cover this gap? We can multiply here by 3. Simple. Okay. Then again there is Mg plus O2 gives 2 and gives MgO. So how would we balance this? So there are two oxygen atoms, right? So Mg plus O2 gives MgO. Okay. So if we would multiply by 2 over here and 2 over here, so it would be a balanced chemical equation, right? Okay, great. So then again, next reaction is CaO, calcium plus water gives CaOH2 plus H2. Okay, so we would write it over here. The reaction is Ca plus H2O gives CaOH2 plus what? Plus H2. Okay, plus H2. So how would we balance this particular reaction? There is just one calcium atom, right? Over this side as well as this side. There are two hydrogen atoms and one oxygen atom. Okay. And here there are 2 plus 2, 4 oxygen atom and 2 oxygen atoms, right? So 4 hydrogen atom and 2 oxygen atom. So it looks quite simple that if we would multiply it by 2 over here, so there would be 4 hydrogen atom and 2 oxygen atom, whereas over this side as well, 4 hydrogen atom, 2 oxygen atom and 1 calcium. So it is now balanced again. So Al plus O2 gives Al2O3. So how would we balance this? How would we balance this particular reaction? Okay, so there is Al. So there is Al plus O2 gives Al2O3. So there are 3 oxygen atoms over the product side and 2 oxygen atoms on the reactant side, and 1 aluminium atom and 2 aluminium. So firstly we will balance the aluminium. Okay, so here it is 2, it is 1. So we would multiply it by 2, right? Is it okay? It's not okay as well. Okay. So how would we? So firstly, we will try to balance oxygen. Okay. So it is 2. It is 3. So what if we will multiply it by 2? So it is now 6. We will multiply by 3 over here and 4 over here. Right? Now it is balanced. Aluminium 4 atoms, aluminium 4 atoms, oxygen 6 atoms, oxygen 6 atoms. It is now balanced. Okay. So then with aluminium as well. Now iron with H2O gives Fe3O4 plus H2O. So it is Fe plus H2O gives Fe3O4 plus H2. So hydrogen is balanced, right? It is quite balanced. But firstly, we will see if iron is balanced or not. So iron has three atoms. So while balancing any chemical reaction, we must consider the main species or the main reactants. So because water, oxygen, or hydrogen, these are the primary byproducts, or we can say reactants. So we should balance them after we are done with our main species. So here iron is getting oxidized, so iron is the main species. So iron has three atoms over there. So we would multiply by three on the reactant side. So iron is now balanced. So oxygen has four atoms over here. So we would multiply by four on this side, and hydrogen has now eight atoms, whereas there are just two. So we would multiply by 4 over here as well. And now the hydrogen, oxygen, and iron are all balanced. Right? Okay, so this is also balanced now. Then again, another reaction is KClO3 plus KCl plus O2. So the reaction is KCl, KClO3 gives KCl plus, what is the reaction? KCl plus O2. KCl plus O2. So calcium, oh sorry, chlorine and potassium are all balanced. K one atom over this side, one atom over this side. Cl one atom over this side, one atom over this side. But oxygen is not balanced. So how would we balance this? There are three oxygen atoms over the reactant side and two over this side. So how would we make two into three? So we cannot add, we can just multiply. Okay, so to multiply, we will multiply it by three, and it is six now. So we'll make this six as well. So we'll multiply it by two, right? But now the potassium and chlorine are unbalanced. So we'll multiply by two here as well. Okay, so this is how we are going to write this particular reaction into a balanced chemical reaction. Then again another reaction is Zn plus HCl gives ZnCl2 plus H2. So the reaction is Zn plus HCl gives ZnCl2, right? So plus H2 plus H2. Okay, so Zn one atom over both sides, Cl two atoms, whereas this side one atom, H2 two atoms, one atom. So we'll balance it by multiplying two. Okay, so that's balanced now. Then the next reaction is C3H8 plus O2 gives CO2 plus H2O. So C3 atoms, C2 atoms. So we'll write C3H8O2. So C3H8O2 gives CO2 plus H2O. Right? C3H8 plus O2. We forgot to write plus O2. So total of carbon, hydrogen and oxygen are here. CHO. Carbon 3 atoms on the reactant side, 1 atom on the product side, hydrogen 8 atoms on the reactant side, and just 2 atoms on the product side. Then oxygen 4 atoms over this side and 3 over this side. Okay, so we will firstly try to balance carbon. Carbon, for carbon we'll multiply it by 3, right? So the carbon is now 3, but oxygen is now 6. 6 plus 1. So it is now 7, right? Okay. Then coming to our hydrogen, that is 8 and 2. So how would we make 2 into 8? So we will multiply it by 4. So it is now 4. Okay. Hydrogen is now 4. Sorry, forgot this. So hydrogen is now 4. Okay. 8, sorry. It is 8. It is 8. Carbon is 3. Carbon is 3. Oxygen is 4 over here. And now it is 6 plus 1, 7 over here. So, no, 7. 6 plus 4, 10. 10 over here and 4 over here. So, what to do now? So, we will multiply by 4 over here. So, 4 plus 4 into 2 is 8 plus 2 is 10. So, these are all balanced, right? Okay, so let's move ahead with our chapter. So there are a few definitions. Firstly, there is precipitate. So what is a precipitate? So precipitate is basically the insoluble solid that settles down after the completion of the chemical reaction. So it might be basically white in color or some different color. So it is the particular substance that do not get solubilized in water or whatever solution is there. Okay, so that would be regarded as a precipitate. Then again, there is a term that we usually called as catalyst. So catalysts uh, are basically the substances that speeds up a chemical reaction. So it is speeding up the chemical reaction. So जो chemical reaction आपकी 10 घंटे में हो रही थी, we have introduced a catalyst into that particular reaction, and now that particular chemical reaction is taking place in 2 hours or 20 minutes. So जो काम हमारा 10 घंटे में हो रहा था, we have reduced the time to 2 hours or half an hour or 20 minutes. So that is because of the introduction of catalyst into that particular reaction. So suppose there was a reaction A plus B, A plus B gives gives C plus B, right? Okay. So C plus D have formed. But there was another thing called G that was in the reactant as well as in the product in the same concentration before and after the reaction. So it was going 10 gram. It was found in the reactant in the same concentration. It was going 10 gram. It was coming 10 gram. Okay, so it was not reacted with any other chemical species, or it was not get solubilized. So it was the same after the reaction as well. But it is helping in what? So it is helping in the speeding up of this particular reaction. Okay, so it speeds up. जो काम 10 घंटे में हो रहा था वो इसने इस particular chemical reaction में जाके सिर्फ 20 minutes में करवा दिया. So it would be regarded as what? Catalyst. Okay, so it is a chemical reaction that speeds up a chemical reaction. It is a substance that speeds up a chemical reaction, or it lowers the temperature. Either it is lowering the temperature or adjusting the pressure if it is needed to accelerate that particular reaction without itself being consumed during the reaction. This is important over here, that the catalysts are not consumed during the reaction. सपोज आपने एक केमिकल रिएक्शन में कोई पर्टिकुलर सब्सटेंस ऐड किया. So it was after that particular chemical reaction, it was obtained in the same form. It was not consumed, not transformed into any other chemical species. So it do not undergo any chemical change in the chemical reaction. It is just speeding up the chemical reaction without itself being consumed during the reaction. Okay. So now coming to the next part of this particular chapter, that is types of chemical reactions. So there are certain types of chemical reactions: combination reactions, decomposition reactions, displacement reaction, oxidation reaction, reduction reaction, double displacement reaction. Okay, so let's just discuss these reaction in bit more detail. So first is combination reaction. So when two or more substances are combining to form a single product, that particular reaction would be regarded as combination reaction, right? So when we are burning a particular fuel, either coal or wood, so the carbon plus oxygen would react. Carbon is present in wood. Okay. So wood in wood or in coal, the carbon is present. Okay. So it would react with oxygen because for combustion we know that आग जलाने के लिए we would require air and air में specifically oxygen. Okay. So we would require oxygen and the resulting resultant or reactant would be carbon dioxide. So after burning of coal, there would be release of carbon dioxide. Okay. So in this particular reaction, carbon and oxygen are reacting to form a single product, that is carbon dioxide. So this particular reaction would be regarded as combination reaction because there are two reactants and one product. Okay, two reactants, one product. So the reaction would be regarded as combination reaction. For example, burning of coal or formation of water, right? Formation of water, maybe we have two reactants and one product. So the particular reaction would be regarded as combination reaction, right? Then again, uh, decomposition reaction. The another type or the second type of reactions we are going to discuss are decomposition reactions. So it is basically the reverse of combination reaction. So in combination reactions, we have two reactants and one product. So in decomposition reaction, we would reverse this particular combination reaction. So there would be one reactant and two products. Okay. So uh, it is a reaction in which single reactant breaks down to give simpler products. Calcium carbonate or limestone CaCO3. When it is heated, it gives calcium oxide CaO, which is also called as quicklime, and carbon dioxide CO2. The decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction which is used in various industries. Again, there is silver chloride AgCl. When we put this AgCl in sunlight, it is broken down into two, silver and chloride. Okay. So in combination reactions, there were two reactants, one product. In decomposition reaction, there is one reactant and two products. Okay. So these are quite similar but opposite to each other. Okay. Then again, there is displacement reaction. Another type of reaction we have is displacement reaction. Okay, so it is a reaction in which a more reactive element displaces a less reactive one. Okay, so suppose we have iron and copper sulfate. So because iron is more reactive than copper, so it would result in the formation of displacement of copper by iron. Okay, so resulting in the formation of iron sulfate and copper. So this is also why the iron nails become brownish in color, or the blue color of copper sulfate solution fades because the copper sulfate solution is usually blue in color, but when it reacts with oxygen, when it reacts with iron, because iron is more reactive, so it displaces copper in copper sulfate and results in the formation of iron sulfate. Okay, so in this reaction, iron has displaced or removed another element copper from the copper sulfate solution, and as it has resulted in the removal or the displacement of copper from copper sulfate to form another element, another compound, that is iron sulfate. So this particular reaction would be regarded as displacement reaction. Okay. So suppose we have A plus BC. So it would result in the formation of AC plus B. Okay. So this kind of reactions would be regarded as displacement reactions. Okay. Now another type of reactions are double displacement reactions. So they are similar to displacement reactions but kind of extended ones. So in the previous one we know there was A plus BC resulting in the formation of AC plus B. So this is the type of reaction in which there is AB plus CD resulting in the formation of AD and BC. Okay, so this type of reactions would be regarded as double displacement reaction. So such reactions in which two elements or two group of atoms switch places between two different compounds are called as double displacement reaction. For example, there was Na2SO4 sodium sulfate plus BaCl2. So SO4 is now reacting with Ba and Na is reacting with Cl. Okay, so resulting in the formation of BaSO4 and NaCl, right? Okay, so because sodium is more reactive, so it is reacting with chlorine, resulting in the formation of NaCl and Ba, barium being another reactive species, so it is displacing sodium and now reacting with sulfate, right? Resulting in the formation of barium sulfate and sodium chloride. So, double displacement reactions basically involve two element exchanging places. So, in the displacement reaction, there was just one more reactive species which was displacing another species and forming in the resulting in the formation of a single compound. Okay, but in this particular reaction, in double displacement reaction, there are two group of elements or two elements which are switching places in between, right? Okay, so next, another type of reactions that we are going to discuss are oxidation reactions. So, oxidation reactions basically refers to the addition of oxygen or the removal of hydrogen. So, oxygen is getting added, whereas the hydrogen is getting removed. So, either oxygen would get added or the hydrogen would get removed. So, in any case, there would be oxidation reaction, right? If a this is the first condition, okay? So, another condition is if a substance gains any oxygen during the reaction, it is said to be oxidized. So, the particular element or the substance that is gaining oxygen. So, if I am gaining oxygen, so oxygen is getting added to myself, so I would be said to be as oxidized. Okay. So the surface of copper powder becomes coated with black copper oxide. Why? Because uh, why this black substance is formed? Because the oxygen is added to the copper and copper oxide is hence formed. So there was copper reacted with uh, So there was copper reacted with oxygen and hence resulted in the formation of copper oxide, which usually appears as a black substance or black coating over the surface of copper. Okay, so here copper is said to be as oxidized. Copper is getting oxidized because oxygen is getting added to copper, right? Then another type of reaction that we discuss is reduction reaction. It is just opposite to the oxidation reaction that we previously discussed. So if a substance loses oxygen, so in the oxidation reaction, we were gaining oxygen. So if a substance loses oxygen during a reaction, it is said to be reduced, and the reaction would be regarded as reduction reaction, right? So there would be an addition of hydrogen and removal of oxygen. In the oxidation reaction, there was addition of oxygen and removal of hydrogen. Opposite to this, in reduction reaction, there would be addition of hydrogen and removal of oxygen. So when oxygen gas is passed over the heated material, that is CuO, copper oxide, that was previously formed, right? So when we pass hydrogen gas to copper oxide and we heat this particular element, then that black coating disappears from the surface and the surface turns brown as the reverse reaction takes place and copper is obtained. So we can again obtain copper in the similar form. So in this particular reaction, hydrogen is added and oxygen is released or removed in the form of water. So these are the two most important reactions, reduction reaction and oxidation reaction. In oxidation reaction, there would be addition of oxygen and removal of hydrogen. So the species that is gaining oxygen would be regarded as oxidized, regarded as to be oxidized. And opposite to this, in reduction reaction, there would be addition of hydrogen and removal of oxygen. And any species that loses oxygen or gains hydrogen would be regarded as to be reduced, right? Okay, so this suppose this is a particular reaction. So in this reaction, both oxidation and reduction are taking place. So CuO is reacting with hydrogen to form Cu. This is a reduction reaction because there is addition of hydrogen. Whereas hydrogen is reacting with oxygen to form water. So this particular segment of this reaction would be regarded as oxidation. So copper would be regarded as to be reduced because it is undergoing the removal of oxygen or the addition of hydrogen, right? But hydrogen would be regarded as to be oxidized because it is resulting in the formation of addition of oxygen in the form of H2O because oxygen is getting added to this particular reaction. So it would be regarded as oxidation and hydrogen would be regarded as to be oxidized. So there are a few effects of oxidation reactions in our daily lives. First is corrosion because it is a very similar phenomena for us. When iron reacts with oxygen, any iron, if we keep that particular iron or an iron nail in open, so it would react with the moisture that is present in the air and with oxygen, which is also present in the air, and there would be the formation of rust. So the iron, when it reacts with oxygen and water, so it would result in the formation of Fe2O3 and H2O. So iron is getting oxidized because there is addition of oxygen and resulting in the formation of iron oxide. So this is a very common phenomena. आप लोगों ने देखा होगा that जब बहुत टाइम तक कोई आयरन रखा रहता है and we do not paint it, तो उस पे कुछ rust लग जाता है that okay, that is usually brown in color. So that particular process is regarded as oxygen, and there are a few prevention measures for corrosion that are we can paint it, we can grease, oil, or galvanize that particular iron. Okay, so this is the most common example or effect of oxidation reaction in our everyday life. Then another example of oxidation from our daily life is when CDT, that is oxidation of fats. So when we oxidation of fats and oils leading to bad smell. So whenever any substance decomposes, so it would start to smell bad. So that particular reaction is known as rancidity. And to prevent rancidity, we often use antioxidants, refrigeration, storing in airtight containers, etc. So when we keep our food in open for a very long time, so it would start to smell bad because the oxidation of fats, because the fats that are stored in that food would start to get oxidized, and that would result in the release of very bad smell. So to prevent this, we often refrigerate our food to prevent from rancidity. Okay, so this was another example of effect of oxidation in our daily life. So that was it about this chapter. Let's quickly recall about whatever we have discussed. So a complete chemical equation represents reactants, products, and their physical states, either solid, liquid, gaseous, or aqueous symbolically. Okay. So in chemical reaction, we are writing with the help writing a chemical reaction with the help of symbols. Okay, then again, a chemical equation is balanced so that the number of atoms of each type involved in a chemical reaction are the same. So this is mentioning about the law of conservation of mass. So the mass of each atom, each element should be equal on both sides of the reaction, either product side or the reactant side. Then again, in a combination reaction, two or more substances combine to form a new single substance. And opposite to this, in decomposition reactions are opposite to combination reaction. In decomposition reaction, a single substance decomposes to give two or more substances. Then, in a reaction in which heat is given out along with the products are called as exothermic reactions. So we must keep in mind that there are two type of reactions. First is exothermic, second is endothermic. Please do keep these terms in mind that in exothermic reactions, the reaction is giving out heat. Okay. Whereas in endothermic reaction, the reaction is requiring heat. Okay. So there are endothermic reactions. Okay, and exothermic reactions. So in endothermic reaction, we need to give heat in order to make that reaction occur. Whereas in exothermic, the heat is released as a result of a reaction. So the reaction is taking place, and that is why heat is getting released into the atmosphere. So we are combusting a particular type of fuel. Okay, we are burning coal, and because we are burning coal, so it is resulting in the formation of heat. So this is a type of exothermic reaction. So it is resulting in the formation of heat or giving heat. Then the reaction in which energy is absorbed or the heat is absorbed are regarded as endothermic reactions. Okay, so when an element displaces another element from its compound, a displacement reaction basically occurs. Okay, yes, we have discussed if two different atoms or group of atoms, ions are exchanged, then it would be regarded as double displacement reaction. Then again, precipitation reactions produce insoluble salts. Precipitation is about something, a substance that do not solubilize and settles down over the bottom of the container. So these are regarded as precipitates, and precipitates are formed in the precipitation reactions. Then reactions also involve the gain or the loss of oxygen as well as hydrogen by substances. So in oxidation, there would be gain of oxygen or the loss of hydrogen, and in reduction, there would be loss of oxygen and gain of hydrogen. So This was it about chapter 1, that is chemical reactions and equations. Do follow your NCRTs and practice more as many as questions as you can. So that was it for today. Thank you. Bye. Good night.